Hello everyone, welcome to my mini symmetry lesson. Today we are going to pretend that we are in day 2 of a lesson on symmetry. So our goals for this lesson include learning goal 1. You will write a definition for mirror symmetry based on examples and non-examples. And learning goal number 2, you will find the line of symmetry for a variety of pictures. Now, learning goal number 1 is actually what we did yesterday. We played a game called This is a Mingo, where I showed you examples and non-examples for mirror symmetry, and you gave me definitions until we finally came up with a class definition that we agreed we would use for the rest of the lesson. Excuse me. So here I have a summary. This is not the complete game, but this is some of the highlights of what we put in for our collection of examples and then non-examples of objects or items that have mirror symmetry. So this was our set. And you notice that we have a lot of similar things, so 2 of a baboon to show that it's not about the baboon itself, but about the particular image and the way it's shot. Same thing with 2 flowers. One of them has mirror symmetry and the other one does not. Now, today we're going to pick up with our definition, excuse me, which is what we came up with yesterday as a class, and we said if an object has mirror symmetry, then you can draw a line through it and the image is the same on both sides. And so what we're going to do right now is just do a quick check about our definition to make sure that we're all on the same page, so to speak. So I have a picture here of a topee. This is a type of antelope. And I'm going to bring up our poll. And I'm going to ask, what do you think? Is this symmetric? And of course we know that we're speaking about mirror symmetry only. And so what you would do is take your cell phone and send a message to 37607, that's right here, 37607. And if you think the answer is yes, in your text you would put 360197. If you think the answer is no, you would put 360198. And if you're not sure, you would put 360206. And the results will go in, and we would see these live as they come in. So I just sent a message. Excuse me, I'm sorry, I have something in my throat. I just sent a message as an example so you could kind of see how it would work. And I put not sure. And the reason I did that is because what I want is for us to take our class definition and recognize that there may be times where we're not all in agreement, okay? And maybe we would be here for the topee because he actually does look pretty symmetrical, but maybe we're not when it comes to something like this gate. You know, some people may look at certain things and say, yeah, I'm not sure. And so today's lesson is actually all about how we can tell for sure and will help us determine the line of symmetry for the variety of pictures that we're going to explore. Okay, so we're going to go to kind of part B, if you will, to this lesson. And what I'm going to do is I'm going to take a series of pictures. I'm going to start off here with one of the Eiffel Tower. And I'm going to have the original image here off to the side. I'm going to move this over just a little. And the other image I'm actually going to attach, if you will, to this quadrilateral that I have constructed over here. And I'm going to use Sketchpad to explore whether or not this image actually has a line of symmetry. Okay, and the way I'm going to do it is this. I'm going to move the quadrilateral so that at least some of it overlaps the picture. And then I'm going to select the picture and the quadrilateral, and I am going to crop that picture to the quadrilateral. Now when I do that, you might think, oh no, the picture's actually gone, but it's really not. If I move the quadrilateral over, you see that it's all still there, okay? And actually this is a key in kind of how we're going to explore this. So you notice that I have this side of the quadrilateral right now highlighted. That's because I want to mark that side as the mirror of reflection, the line of symmetry, if you will. So I'm going to mark the mirror. You see the little animation. And then what I want to reflect or show the symmetry for is the picture itself. So I'm going to select it, and I'm going to go to Transform, Reflect. Now as soon as I do that, you can see that this now becomes the fold line, if you will, or the mirror line, or the line of symmetry for the picture. And I can move that and adjust it in any way to try to determine if there's some way that I can put this in order that the images actually match. I think I'm pretty close right here. What do you think? That looks pretty good to me. So in other words, had we voted on this image and several people said, oh, I'm not sure, then we could have proven that the answer is yes. This particular image does have mirror symmetry. Okay, so if we go back and we want to check our topi, for example, I'm going to select that and copy it, and I'm just going to put it over here and let it be my reference image now. Okay, and I'm going to now copy it here, and then we can explore to try to find out, does this topi actually have a line of symmetry? I think I'm pretty close. What do you think? Now, we would, if we were doing this with students, of course, we would want to talk about the piece of the body that's still showing up in the picture, because obviously it's off to only one side in the original, but the whole thing is being reflected here. So we would need to ask our students to concentrate on just the face. Now, if you're way better at Photoshop than I am, maybe you'd be able to just take the face out and not have the background and the rest of the body in there, but I actually wasn't that talented. Okay, so let me go back to this one of the gate, and let's see if we can check it. Whoops. That was entirely too many things that I pasted. Get rid of that extra. And let me make this a little bit smaller. That looks better. And we're going to see, I think, something kind of interesting here. All right, so here's the original. Here's the copy. Now, this actually looks pretty close. Let me move this over a little so we have a little more room. But if you look in a little more detail, do you see this here on the right-hand side of the gate? There's actually a door. And in this version, there isn't. And that's, of course, because we're reflecting only the left side, the side without the door. If we wanted to see what it looks like with the door in it, we could actually reflect the right side, and then we'd see actually two doors. And what this tells us is when this image and this image don't look exactly the same, then our image, our picture here, does not have perfect mathematical mirror symmetry. And this often happens in sort of real life. So speaking of real life, let's talk about people. So here's our original picture, this girl, that I got this actually off of Sketchpad's collection of photos, so this isn't one of mine. And here we have the line of symmetry drawn in, and it looks pretty close, actually. She looks pretty symmetrical. But if I flip it over Do you notice it almost looks like she's an entirely different girl? Right? So this is just to illustrate that mathematical symmetry and symmetry in nature or in people, it's often not exactly the same. Now, in the real lesson, we would go on and explore this some more. We would explore with some more pictures. You see that I have a bunch of different pictures that we could do things with. And we would also explore with some things from the Sketchpad website. So for example, we could explore symmetry in terms of letters and numbers, images that are text, geometric shapes, all kinds of different things. And from there, we would discuss other types of symmetry, including rotational symmetry and translational symmetry, which is what I have illustrated here in this extension. And we could continue with this by switching out the image from the flower to other things and discuss the two other kinds of symmetries as we go on in this lesson. And then finally, I'm going to end with discussing how the assessment would be on this lesson if we were doing it for real. So you saw that we used the poll to check our understanding today. We can vote on a lot of different things. We just did a simple is it symmetric or not. You can also do short answer things like to type in your definition for symmetry and things like that, which we could have used in yesterday's lesson. And then last, as the culminating assessment, I would ask each student to create a virtual 3-ring binder like this one. And prior to assigning this, of course, the students would be given the guidelines for the assessment, and they would be given the grading rubric, and then given the link here so they could see an example of one and what it would look like. So you'll notice this one has several tabs, including links from some other sites. This is a really great video on football physics and symmetry from the Minute Physics guy. I love him. And some information from various sites. This includes all 3 kinds of symmetry and some examples, some sort of homework type questions. This is a really great discussion from the Math Forum that talks about the 4 kinds of symmetry, so it includes a combination that we haven't talked about yet. A really great site here about symmetry and tessellations that talks about the different kinds. And a cool article about a brand new kind of symmetry that was just discovered last year called rotation reversal symmetry. A really cool site that has all kinds of links about symmetry on the Symmetry web quest. And then finally a tab on symmetry and algebra, specifically in graphs of equations and functions, that we talk about the different kinds of symmetries there. So the students would be given this as an example to go by, and they would also be told as part of their guidelines that none of the items that are in my binder would they be able to use. So it would be up to them to go find new binder information. Okay, so that is the mini lesson. I hope you enjoy it, and thank you very much.